All right, so for those who are first-time attendees, the eSIP information quality cluster identifies challenges and the solutions in providing better quality information for all. So our members have been actively participating in activities so in different organizations such as eSIP, NASA. We have published recommendations and research papers over the years. So more information about our cluster is available on the eSIP wiki page, and you can sign up for our mailing list as well. So both links are on the session page. So at the last eSIP January meeting, we had a very successful discussion about our about the data product quality. So users want a high quality data, especially long-term, consistent, bias-free, low latency, historical, real-time, or forecast data. So organizations need to adjust their programs to meet these requirements. So for today's session, we will focus on the information quality associated with open science across disciplines, in particular, identify information quality challenges, community collaboration opportunities, identify solutions, such as recommendation, best practice, and develop the partnership among the different organizations for the IQC. So there's a lineup of speakers covering different topics today. So each presenter will have 8 minutes to present and 2 minutes for transition and burning questions. So Q&A and the discussion will follow. I hope you enjoy this session. So without further ado, I will let my co-chair, Dr. Gepeng, introduce our first speaker. Thank you.
Hello, everybody. It's my privilege to introduce Chris Schubert, who is who's coming to us from the University Austria Library and who has been involved in a number of international efforts, including GEO's data sharing and data management principles. Since 2022, he has been the co-chair of European Open Science Cloud Task Force, Fair Metrics and Data Quality, that he would talk to us about it today. Chris, take away.
Yeah, thanks. Thank you. No, thank you very much. First of all, I have to apologize not to be there in person. So currently, I'm in vacation, but it's a grateful opportunity here to talk to you and present what we are doing within the European Open Science Cloud. My name is Chris Schubert. I'm located in Austria, in Vienna, head of media management and library IT. And I want to give you some insights of our task force for what we are doing. And plan to do. Together with Mark Wilkinson, he's one of the main author of the FAIR Principles. So we are steering as co-chair these task force here. Mark Wilkinson is responsible for the FAIR metrics and assessment, and I'm responsible more for the data quality aspect. So in the end, we are a group of cross-disciplinary experts here from 70 countries at the moment in Europe. We started in 2021 for this task force. So our mandate is running for 2 years. And working together with frequent meetings. So every frequent meetings and interviews, survey, and so on. together all the perspective with for the needs for the European Open Science Cloud. Just a quick slide here about the task force in general. So we have to explore the issues related to governance of fair evolution, and also pointing out the inconsistency between fair assessment tools. The FAIR principles does not cover the data quality aspects, and this is our part where we have to work on it. So and we have to find arguments and to bring data quality information a little bit closer to our stakeholders within the European country, within the European Open Science Cloud, and in the entire research ecosystem. So also a short sentence to the European Open Science Cloud. In the end, this is not a real infrastructure. The European Open Science Cloud is more an agenda for development, for funding programs, for research investments in Europe within a long-term perspective here. So dataset quality, and we are dealing with at this task force more on dataset quality, not the accuracy of data itself. So dataset quality or information describes the issues of instruments, variables, and to make parameters explicitly, also measurement, collection, access to software tools, software frameworks, and to support the entire life cycle of data sets. So in the end, we are dealing in theory aspects here on the quality of data, on the quality of metadata, and the surrounding documentation of data sets. Also facing to software workflows and data processes here. So, and just the definition, as we understand the data sets, it's a identifiable collection of data. So it doesn't care if it's in the data set database, if it's a single data files or something else. You know? So super objective in the end is really to get or to reach and achieve a trustworthiness and transparency here within the entire life cycle, generating data, and also data quality, dataset quality by design can and should be an effort for the near future. Yeah. So in this session and also in this community, I don't have to go too in detail why we need quality information, but the important thing is really trustworthy or trustful data to support decision-making processes. Also to discover the cost effects on low quality data and high quality, or versus high quality data here. We have also to support the reporting around data set, around data processes, and find out understandable and explicit expression for data quality, which can be used and adapt by different scientific domains here. So these text slides, so it's just what we are doing. So, and also our group, we started in 2021, I mentioned. So as the first step and effort was really to get also a common understanding about quality, about data quality approaches, who's the actor who's involved, or about the actors who are involved, also the workflow management and certification and potential quality aspects here. So we did a lot of work in a desk research about literature, about existing standards, ISO, OGC, for example, and out of them we tried to create a crosswalk and to describe the dependencies between them. So as I said, so surveys are a nice tool. Related interviews to them are much more effective in the end to get more the detailed information we need. And beginning of this year, we bring out a document. It's an 80 pages document, which is called Towards Data Quality Framework for EOSC. And we started also an open consultation process, so a global open consultation process together, the perspective outside of Europe here. Yeah, and that's why I mentioned also this joint effort and joint review. So here you can see the NODO DOI, where the document is available and will be available. And our action for the next month is also to get more in to reach out the overlapping of other European Open Science task forces. There are 13 in place at the moment. So, for example, semantic interoperability, PID management, technical interoperability, or data preservation, so that we can have an adapted version end of this year. And also the cooperation aspect is quite important for us, really, to start this, and we get in touch with ESIP, we get in touch with the Australian, New Zealand data quality interest group, to have also an idea how we can, or if we are able to find a platform like RDA for a common discussion. Now I will come to the multidisciplinary aspects, and our process is really to understand the different requirements of the different communities. And in the end, the result, it's quite simple sentence, so that each discipline is a unique one, but have similar needs and similar challenges to step in and to solve and overarch them. So, and we have to find out the common interest by sharing, by learning together and sharing knowledge and best practices across the disciplines here. And one aspect, this is what, almost the last slide here, is so this is just a list of our expertises or field of expertises within this task force. A huge number, of course, is related to the ISO 9000 or 90,000 ecosystem. So for the technical committee 211 and these standards. But we have a lot of disciplines which are not really mature on this level for geographical or spatial data. So, and one aspect we want really to start is on focus on semantic artifacts here to identify core components which can use as within a cross-disciplinary aspects. So just as example, I don't want to read so these some of these requirements. So this is just an example from the January here, but in the end we have to my major interest is really to find formalized information and publish also this information here. So due to the time, I will stop here, and but really happy to discuss this within this session here, and also afterwards I'm available for any question and discussion. Thank you.
Thank you, Chris. Okay, for the interest of time, we probably should put the question later in the Q&A and the discussion. So our next speaker is Dr. Jennifer Wei, Unfortunately, Jennifer is not here. We're gonna play her video. Where's the video? In the battery, yeah. I think that's the harness. This one, yeah, this one. Okay.
Hey everyone,
Okay.
I'm Jennifer
Let's
Wei.
pause first.
Today I'd like to share my recent experience in developing a new open source application. I'll be discussing the potential of open science.
Oops. Sorry about that. Let me introduce her first. Okay, Dr. Wei is the lead scientist at the Goddard Earth Science Data and Information Services Center, also known as JASDISC. She's also a project scientist of NASA Earth Science Data and Information System, ESDIS project. Unfortunately, Jennifer is not available today, so we're gonna play her pre-recorded presentation. Great, thanks.
Hey everyone, I'm Jennifer Wei. Today I'd like to share my recent experience in developing a
So we don't see the slides remotely.
I'll be discussing the potential of open science and the information quality challenges that I encounter while harnessing NASA Earth data. Before I dive into the details, I am so sorry for not being able to join you in person, as I'm currently attending another section concurrently at the ESID.
Now we see this. Now we see the slides.
Okay, let's start again.
Hey everyone, I'm Jennifer Wei. Today I'd like to share my recent experience in developing a new open source application. I'll be discussing the potential of open science and the information quality challenges that I encounter while harnessing NASA Earth data. Before I dive into the details, I am so sorry for not being able to join you in person, as I'm currently attending another section concurrently at the ESID. However, I'm very thankful for this opportunity to talk about advancing open science through information quality using NASA Earth data during this meeting. Now, when it comes to open science, the NASA TOPS teams has made a significant strides in promoting open access to data, findings, and methodologies. They foster collaboration, prioritize transparency and reproducibility, and aim to democratize scientific knowledge. However, today I want to shift the focus on my personal experience with open science through my work on Pyroscope Greeting, which is an innovative open source package that I recently developed. This project has not only allowed me to explore the possibilities of advancing scientific work under the guidance of open science principles, but also presented unique challenges along the way. And by sharing the lessons that I have learned, I hope to inspire and contribute to the collective pursuit of even greater achievements in the field of open science. So what is Pyroscope Greeting, you may ask? It is an open source application designed to fuse aerosol products from multiple satellites, including geostationary and polar orbits. This fusion process, as you can see in the figure, harmonizes level 2 data from 3 GEO and 3 LEO sensors, providing a comprehensive perspective on aerosol products. By addressing disparities in spatial and temporal resolution, Pyroscope Greeting enables researchers to manipulate and analyze aerosol data according to their specific requirements. Therefore, Periscope Greeting offers the following capabilities that fulfill these requirements. First, it has to capture the diurnal cycle of global aerosol optical depth, AOD in short, based on the Earth observation across different scales, offering insights into aerosol behavior throughout the day. Then it can also handle big data, making it well suited for cloud computing environments. So researchers can fuse remote sensing products on the demand, tailoring the temporal and spatial domains to match their own interests. So the development journey of this Periscope Greeting was driven by the goal of enhancing our understanding of aerosols' impact on air quality, climate, and human health. Furthermore, it empowers evidence-based decision-making and policy development by providing such a reliable scientific data. So it sounds pretty good for the Periscope Greeting, huh? But when we developed this Periscope Greeting, we encounter several challenges related to information quality along the way. One significant challenge was ensuring data accuracy and reliability. We had to navigate different algorithm versions and even the open source libraries version to make sure that we can achieve the data consistency and have a dependable results. Moreover, addressing the disparities in temporal spatial resolution among satellite products already created data gaps that require substantial efforts for us to accurately analyze the aerosol data. Of course, capturing the diurnal variation of AOD itself poses its own set of challenges. So another critical challenge that we face was ensuring reproducibility and scientific rigor. To overcome this, we have to work closely with data producers, implementing rigorous quality assurance and quality measures. We also place great importance on providing comprehensive metadata, recognizing its role in ensuring reproducibility and facilitating a clear understanding of the data. We also encountered the limitation in existing metadata checking tools, emphasizing the need for dedicated data and metadata validation tools. Consequently, we dedicated ourselves to providing extensive metadata and documentation to enhance the ease of understanding and the data reuse for these services. Of course, the data reuse and collaboration present their own unique challenges as well. To address this, we adopted efficient data management techniques and tackle consideration related to the storage and migration. Furthermore, we have to prioritize trust, credibility, and ownership, and data stewardship to foster collaboration among stakeholders. And all these challenges represent some kind of major obstacles as we encounter during this development for the Periscope Greeting. So I have discussed some of the challenges that I faced when I developed Periscope Greeting in terms of information quality from previous slide. So here I offer some of the potential solutions that I think in order to enhance information quality, which include standardizing data formats and metadata, which we may be able to utilize cloud platforms and GIS application, implementing data quality assessment and validation processing, and improving documentation and metadata completeness. Establishing data governance and management policies and fostering collaboration are also important. These measures ensure accurate, reliable, and comprehensive data which drive innovation and enable transformative discoveries. I thank you for your time. Here is my email information. I look forward to seeing you and discuss with you during this meeting. Thank you.
Well, Jennifer is not here, so I don't know if you have any questions. Yeah. So David, could you introduce Michael?
So our next speaker is Michael Garay, who's from JPL, Jet Propulsion Laboratory. So Michael is the validation scientist for the upcoming joint NASA ASI multi-angle imager for aerosols, also known as the Maya mission. He is also a co-investigator on the NASA multi-angle imaging spectroradiometer mission, also known as MISR, where he has served as the aerosol algorithm scientist. At JPL, he is a member of the Scientific Understanding from Data Science Initiative, also known as SUDS. So without further ado, let's welcome Michael.
Okay, great. Thanks a lot. Hopefully everybody can hear me. So my name is Michael Garay. I'm a scientist at JPL. And this is more of a view from the trenches as opposed to these high-level talks we got before. But I'm going to be talking about this new mission called the Multi-Angle Imager for Aerosols, or MAIA, which is unique because what we're doing is we're trying to go all the way from satellite remote sensing to epidemiology. And I'm giving this talk, but I'm actually pinch hitting for my boss, Dave Diner. So just a really brief introduction about MAIA, but so particulate matter air pollution is the top environmental health risk according to the Global Burden of Disease study. So if you look down here in number 6, ambient particulate matter pollution causes more than 4 million premature deaths per year. There's lots of different diseases that are attributed to air quality issues. And we're talking about particulates specifically. So the one question that we really want to answer with MAIA is, what are the components of particulate matter, and particulate matter that's very small that can get into the lungs, which we call PM2.5? Which ones of those are the most harmful? And that's actually not something that's well understood. So if you breathe in a particular type of aerosol, it may have adverse health effects in one place, or if it's a different type of aerosol, may have different health effects. And so we really want to understand that, because that actually really helps target mitigation efforts. And so what's actually out there is a mixture of a lot of different things. And so that's really why we want to be able to figure out what exactly is in the air that people are breathing. So there's a real important reason we want to do this from space, because ground-based monitors exist. And so that's where all these studies have been done in the past. But there's not very many of them. So if you look at the map in the upper left-hand corner, you can see all these little dots, and it looks like we have good coverage, but there are large portions of the globe where we don't have any coverage, and the gaps between these monitors can be quite large. These are very accurate, but they don't provide very good coverage. On the other side, satellites, you have to infer what's happening on the ground, but you have pretty good accuracy, but you have these spatially continuous maps. And so this is the idea really of MISR, is we want to infer what's going on on the ground using satellite remote sensing. We built on heritage from the MISR instrument, so that was mentioned before. So we were selected back in 2016 as a Earth and Venture instrument investigation. And as I mentioned, we're looking at aerosol types. So we're looking at things like sulfate, nitrate, organic and elemental carbon, and dust. And that's really what the mission's all about. I should point out that this is designed to be an epidemiological mission. So that means we have epidemiologists on the team that are going to study the health effects of these different types of aerosols. So we like to show this picture, and this is it shows these key elements. We actually have 4 parts to it. So going from left to right, we have the satellite instruments. There's a picture of the instrument. It's actually completed at JPL. On the ground, we have the existing surface monitors, and we also have models. We have what are called chemical transport models that can predict how much aerosol is in the atmosphere. And those are part of what we call our public product. On the far right-hand side, we have the health records, but those are privacy protected. So they have personally identifiable information. So, health records associated with zip code, for example. So we actually don't touch those things. Those are actually entirely part of what the epidemiologists are going to do. So that's birth, death, and hospitalization data. And so combining these two together gives you these epidemiological studies. And so this is this interdisciplinary aspect of MAIA. We have a whole bunch of research scientists like myself. We have a bunch of engineers that are putting the thing together. We have people that are experts on surface monitors, on modeling. And then on the other side of it, we have these epidemiologists who are interested in understanding health effects and understanding, what kind of diseases are being caused by these different types of aerosols. So the types of epidemiological studies we're looking at are things that are what we call acute, so they happen within days to weeks. So in each one of these little target areas on the left-hand side are places that MAIA is going to be observing. So we have acute effects, we have subchronic effects, which take place over months, and then we have chronic effects, which happen over a long period of time, over years. And so MAIA is scoped to be a 2 to 3 year mission, and so we have the ability to look at things like birth outcomes, which take 9 months, or things that happen over multiple years on the far right-hand side. So the first aspect that I wanted to focus on here after talking about MAIA is about the open science. So we have to be able to talk across communities. And this is a challenge that we've kind of just ran directly into. And so two of the communities we work with are the in situ community, which are the people that work with the surface monitors, and the remote sensing community. And we actually have different languages we talk about. So in situ talks about math and composition. We from the remote sensing community talk about indirectly things like in Jennifer's talk about aerosol optical depth. They're used to working in situ data is sparsely distributed. We're used to using dense sampling and maps like this. And so we had to come up with a way to talk between these two communities. So the way we got through this is translation to a common language. We want to basically be able to present all of the data in the same language rather than just using the data from one community. So using the language from one community. So what we've done is we've learned to kind of translate all of our satellite phraseology, I guess, into surface monitor phraseology. So everything is discussed in terms of PM 2.5, but you can't just relate optical depth to PM 2.5. That doesn't work very well. So that's what the plot on the left shows. On the right, if you take additional information like relative humidity and wind speed, you actually can get very good agreement between the predicted PM 2.5 and the observed PM 2.5. The way we're going to do it for MAIA is we're going to use something called geostatistical regression models, which incorporate spatiotemporal effects, aerosol optical depth measurements, geospatial predictors like elevation, population density, and green space, and then meteorological variables, as I mentioned. Importantly, the input data will be archived and provided to users as a separate data product. So what that means is we develop these models, we provide PM 2.5, but if you as a researcher want to go and do it your own way, and you have a better way of machine learning or something else, we provide the data to you to allow you to do that. So that's the open science aspect of it. I should point out that the next piece is information quality. So we're a targeted mission. So here are the different targets where we actually don't observe the Earth continuously, but we observe these different targets all over the globe where we have particularly epidemiologists. So the blue points are the places where epidemiologists are already part of the MAIA team. They're going to do the investigation. So there's a lot of things I can talk about in information quality because that's what I'm working on. I'm the validation scientist. But one of the things is we're preparing for the MAIA investigation. So we've been doing these time series analyses to understand long-term trends. So this is just two examples from Italy, and it's showing a decrease in the overall aerosol optical depth, which means that the air is getting cleaner, which is great for health, but it makes the retrievals difficult because the signal gets smaller. And I wanted to point out that we actually have early adopters. We have over 200 members of our early adopters team. And this has been really helpful because we have members from all different kinds of communities that are providing us really useful feedback in terms of how does the data look? Does this make sense? And are we giving people the right thing? So just to summarize, we have these two effects. We have these open science piece where, we have a science team that includes remote sensing scientists, epidemiologists. The raw data will be provided to users to use different ways. The early adopters have been really critical to giving us initial feedback. Information quality is really, really important to ensure high quality. It's already been mentioned. Pre-flight analysis of data quality is going on right now in target areas. And we have to precondition the input data using these regression models. So it's having trusted data. So we're not giving people garbage data, but we've actually quality controlled the data as we go in. And we're looking for launch in 2025. So that's the talk. Thank you very much.
Okay, thanks, Michael. Okay, my daughter is going to medical school end of this month, so she's also interested in public health. So I always point her to the NASA data and other data set. So our next speaker is Dr. Benita Casey. Benita Casey is the user need lead at the NASA JESDISC. He leads the NASA ESDSWG for interdisciplinary user needs. She's also a deputy manager for AdNet Systems Inc. at the JESDISC. Okay, what's yours? Do I need to, let's see. This thing is, you know how to use Windows, right?
All right. Good afternoon, everyone. I'm Benita Casey, and sorry, what was? Oh, okay. Yep. Cheers.
Green.
Good. All right. All right. So today I'm going to talk about interdisciplinary users and their needs. And I'm talking, most of my talk is focused on the findings from the ESDSWG Interdisciplinary Community Needs Working Group. And before I start, I would like to acknowledge my colleagues. Irina, she's here, Elizabeth, and Mukul Sonwalkar, Jong, who has been actively working in the working group and have been providing feedback, and thank you for that. Okay, so to the next slide. It's not advancing. Okay.
Sorry, which way are we going?
Up here. All right, thanks. So I'll start with some background and I'll talk about the workflow that we use to identify actually the data sets and services that are used for interdisciplinary studies. And I'll talk briefly about need assessment. So if you look at this chart, the graph on the left, it shows, it's taken from a paper published in Nature in 2015. And they look at the papers that mention like interdisciplinary in their title, and they found out that social sciences and humanities, more of the papers are mentioning interdisciplinary in their title, and less natural sciences and engineering discipline is mentioning that interdisciplinary word in their title. So we have some work to do in terms of natural sciences and engineering. And if you look at the graphics on the left, then you can see that the references that are used in social sciences are from disciplines other than social science. So they are like more incorporating more like interdisciplinary aspects than natural sciences and engineering are doing. This is the graph that we took from Web of Science research areas that use EOSDIS datasets, and they are derived from 10,000 peer-reviewed publications that are using the EOSDIS datasets for different application areas. And you can see the graph that it's we're very used to seeing that our data sets have been used in the environmental sciences and ecology, geology, meteorology, atmospheric science, but we're not used to seeing our data sets used in the optics, life sciences, medicine, and other disciplines. So the use of the data set is increasing into it's broadening, and different disciplines are using our data sets. Therefore, we need to identify the interdisciplinary areas and identify which data sets are co-cited with in terms of those interdisciplinary areas. So I'll share a workflow that we have developed and have been working actually through this working group. So the first we selected a use case, and water, energy, food nexus was one of the interdisciplinary use cases that we selected, and we identify a bunch of science keywords that are representative of that, that are representing that interdisciplinary research. And the workflow is that we have actually Irina has developed a EOSTIS publication library. She's working with other DACs as well, and that publication library has publications from that are using the EOSTIS datasets, and we feed these keywords into that publication library, and that help from that keyword, it helps us to derive the datasets DOIs. And using this dataset DOI, now we do the CMR query and identify the data collections that have been used in that particular interdisciplinary studies. And I'm going to share that in the next slide, but we are right now successful in getting the data collections, getting to the data collections from the keyword, but also we're also want to look at services and map those data collections with the tools and services that serve the data set, but we are not there yet. So this is for water, energy, food nexus publications. We identified 2,451 publications using the keywords that I mentioned earlier, and there were you can see that there is a breakdown by the keywords, and when we talk about energy, food nexus, drought is definitely one of the keywords that comes to our mind, flood, growing season, and we also had the other keywords such as famine, water, energy, and food demand, water production, and all this, and you can see the publications related to that keyword. And on the graph on the right, you can see the time series over time series from 2005 to 2020, and that you see the increase in trend in the citation of those data sets related to that keyword. Among the 2,451 publications, we had 854 unique data collections that were distributed from different DACs across EOSTIS, and you can see the graph on the left shows the DOIs and the number of publication count for that particular DOI. And the graph again on the right shows the that from 2015 to 2020 there has been an increase in the citation of the datasets DOI in the publications. And I really like this chart because this is the water, energy, food data sets, related data sets that are publications that are co-cited. Co-cited meaning that data sets, for example, in terms of, if you look at this one, and there are like 34 publications that use the data sets both from LPDAC and then NSIDC, 46 publications that are related that are from the ORNL DAC as well as from LPDAC. So you kind of see this co-citation, and which is really important because when we talk about interdisciplinary users, they don't just go to one DAC to get the data set. They get the data sets from different DACs, and that's very important for us to know like which data sets goes with other data sets from other DACs. So it's important because when we develop these tools and services, we want to make sure that it serves both of these co-cited data sets. And the map here on the right, these boxes are usually the boxes represent the DACs, and the arrows represent, and these are the DOIs from particular DAC, and you can see that the DOIs or the data collections from one DAC is mapped to the other, and you can see the mapping, cross mapping here. So the more arrows you see from one DAC to another, that means like these data sets have been cited with the other data sets from other DAC. And this year, that was the work done last year. This year, we have started exploring greenhouse gases publications that have greenhouse gases, and we also had the keywords, but I did not put those keywords here. We identified 3,191 publications, and again, keywords. These are the breakdown of the publications by keyword. Carbon dioxide is the most popular one. A carbon cycle, greenhouse gas, and you can see all those breakdowns by different keywords. And the same, the trend from 2005 to 2020 to 20 as well for each of these keywords. As I mentioned earlier, we mapped the data collections from the keyword, and we also wanted to look at what are the services that are like serving these data sets from different DACs, but we're not able to get there because of various reasons. Maybe so it's the services are not properly tagged in CMR. That's where we use to identify the services. So we've been doing it manually, but I think it would be really something that we should keep in mind that they have enough metadata in the CMR, so you know which data set is served by which services or tools. I don't know how we are doing with the time. I'm not gonna go into details, but what the takeaway from this slide is we have developed a user's journey that a user, when they get from point A to point B, what are the different steps that they go through. So for example, if you look at number 1, users first come and explore the resources. The second step, after exploring the resources, they narrow it down. And after they narrow it down, they know what data sets they are specifically looking at, and they are comfortable with that. They now want to access the data set, and they want to customize the data set and analyze the data set, and then finally publish. Ultimately, most of the users they go for publication as well. And the boxes on the each of the square boxes shows that what are the information needs at each of these steps in the user journey. So I'm not going to go into details, but I'm happy to talk after this session. Also, another thing that we are trying to do is we are trying to find out the existing gaps. As I mentioned earlier, like these are the user journeys. The typical user goes from number 8 to number 6. During that, where are the limitations? So we have developed this survey, especially designed for the interdisciplinary users or researchers, where we know like at what point they are struggling, or at what point we are not able to provide enough information to them. So if you this is just a sample chart, and this, if you look at this radar chart, let's say that each of these lines represent the scientist, and they have their feedback on the way that we are doing in terms of accessing the data, exploring the data sets, narrowing down again, accessing, customizing and analyzing the data sets, and publication, and then also the documentation part. And if you see here, this is a ranking from 1 to 5. You can see that we are lacking behind in the customizing the data sets. We are not able to help users to help them to customize the data sets. Similarly, we're a little bit behind on helping users to narrow down the data sets after they do the initial exploration. So this is still ongoing, and we'll hopefully be able to provide more insight after we have many data points. So we're still looking for that. And this is my last slide, my second last slide, and I just want to mention that we wanted to learn by doing it ourselves. So we had submitted this a project in the OpenScapes champion cohort in last April to June, where we wanted to explore different data sets as as a interdisciplinary user. So we had in our team, we had Ranjay, we had Shauha, and I was myself involved, and we're looking for data sets from, for Water Energy Food Nexus project, and these data sets came from different DACs, and we kind of summarized like what worked and what did not work for us as a user. So this is like focus on what did not work is, we explored the data sets in the cloud, and all of those data sets, most of them are in the cloud, but not all of them, of course. But those data sets that are in the cloud were in different formats. So we are using like Python to access it, and one of the data sets was in NetCDF, the other was in SDF5, the other was in SDF. So we had to use like 3 different packages. Though we are using the same language, we were using 3 different packages to access the data set. So, it's kind of really downside and in a kind of like a struggle for interdisciplinary users, because they, if the tools does not work for different data sets, then you will have to use different sets of tools just to get there. And also in terms of data services, we had, some of these services are developing in the cloud, but not all of the data sets are on board. So we're just in between there, and just wanted to share that this insight with you all. Looking forward, we want to explore more interdisciplinary use cases, and we're working towards identifying gaps and produce recommendations and standard practices. And we're also trying to disseminate the information and get more interdisciplinary users engaged in the working group, so we know, where they're coming from. So and so that we can help guide them through. With that, I would like to end. And if you really want to get involved in the working group, here is my email, and here is the listserv that you can use. And we have monthly meetings. So, if you are interested, just let me know. I'll add you to that as well. With that, thank you, everyone.
Okay, for the interest, I will leave the question in the Q&A. Okay, so our next speaker is Dr. Eugene Yu. Dr. Yu is a research professor and associate director at the Center for Spatial Information Science and Systems at the George Mason University. So Eugene, the floor is yours. On share first.
Sure.
Yeah.
Here?
No, unshare the screen first.
Oh, share the screen first.
Yeah. I'm not a window person. So
Stop.
Yeah.
Okay.
And open yours.
Where is it open?
Behind this. Yeah. This direction.
This one?
Yeah. Go find your.
Quality model. Where's the one?
Which one's yours?
This one. This one?
This one?
This one?
This one, yeah.
Okay.
You're good, right? Then you probably need to share screen again for the one.
Now, how do I share?
Yeah.
Here. Can I share the whole screen?
Yeah, share the screen. Oops.
Okay, just share the whole screen, right?
Mm-hmm.
And this one.
This one.
Okay. Sorry.
All right, it's fine.
How do I make it a full screen?
Full screen.
Where is the full screen? No full screen. I should give you the. I give you the PPT instead of the PDF. Anyway, I think I just use this. Oh, sorry. Back. Where is this? This one, right? Which one? Sorry. Where it is? Where's our slides? Here. Sorry. Which one? Where's the slides now? Go. This one? This one, right? No, not this one. Not this one. Sorry. This one. Let's just bring it up again. Sorry. Yeah, here we go. This one? Which one?
Yeah, should try that one. Nope.
No, that's fine.
3 dots.
3 dots.
3 dots.
Okay. Anyway, so I was asked to give this about the data quality models in 2 of those things, ongoing efforts in the OGC, which one is the unnecessary data standard working group, and another is the training data markup language for artificial intelligence. So basically it's encoding the training data. And I saw Dr. Josh Lieberman is here. So he is probably, he's from his OGC lead on those, including the disaster, geodata cube, and also unnecessary data. And he probably is a better person to cover this topic, but I'm here as just a messenger. I probably can add afterwards. So the first one I want to cover is the I think also I want to mention that this is basically also more like a messenger, just passing on the message from Professor Livingdeal, who is he's currently the chair of the OGC IRD standard working group, also the ISO 19176 series, which is also basically the unnecessary data standard working group. And Dr. David Mayer is one of the charter members in this or standard working groups. So more like a passing as messengers. They are not be able to be here on this at this specific time. So let me go this one, right? Is that right? Oh no. Oops. Sorry. This one. Maybe it goes this way. Okay. So outline. Basically just cover those two aspects, which is ongoing in the OGC and also ISO standard working group. And the training data markup language for II is I think just passed the internal voting and to be ready to be released as a standard in the OGC working group. So I think for this one, I want to focus on the what the data quality part play in those standards. And for the unnecessary data, of course, we do need to have those quality information released along with the data, right? So we get, because the unnecessary data is mostly evolved from the CIAS unnecessary data. Probably many of you already know that. So that is mostly focused on the satellite remote sensing data, and also elevated from the more or less is those level 1 or data to be level 2, or you could say that is more like provided the capability of spatial temporal alignments of those data, and also look at the thematical corrections or radiometric corrections, right, in this context. And also for the CIAS IRD, they do have a 2-level metadata, which is one is more, you could say that is more like related to the collection level metadata, which is a general metadata, and the per pixel metadata, or those are more like a focus on the data itself. And so they have this 4 aspects. So that's the aspects of that define those things. And of course, they have the radiometrical correction and accuracy, and the geometrical correction and accuracy. Let me see this one. Okay, sorry, I just wrote it. So look at for this one, I was specifically focused on that the data quality part, I forgot the other part, which is they do have a cover other specific requirements. Either I also have the 2-level requirements, threshold or target. But here we're focused on the what qualitative information is released with those analysis-ready data. With the current CS analysis-ready data, they have for the quality information. If you look at the 2 levels, and I put the number here. I think it's 1 is mostly for the general metadata or the overall of that collection or that data set. And then the others are more like for per pixel or different tests, different condition description of those data. So for the, I went through the template, right? I think it's the CS analysis-ready data template. If you look at through those different items which is related to the data quality part, for the level 1, I only identified that the 1 is the general accuracy, basically provided the overall description of the accuracy of that data set. That's what I found. If anyone find anything else, let me know. But the second, the rest is basically for the per pixel, different quality tests, especially. I think the only one required is a low data test, which is the test for that there's no data. That's the only one required. The rest is just more like a target regard or desired just quality, desired quality of those quality description of those analysis-ready data. And also they have the beside the sorry, and for the of course, this is because it's more leaning towards those satellite remote sensing. So you can see like as a cloud coverage test and those things. And that's might not be able to go to other data. But for the analysis-ready data, of course, we are going to expand it beyond the Earth observation data or non-EO data. So that probably where you will see a little bit different about the specific items to be included into those quality tests. And also the for the measurements, they have a measurement on certainty and also normalization. And also they have the measurement corrections, geometric accuracy. Those are more covered, more or less covered to those 2 themes we are talking about: the radiometric correction and also geometric accuracy. But this is more on the per pixel level, or the depending on how you see, that's probably like the granular level, or more or less on that side. So those are basically I picked out all those data quality information currently in the template, or so basically just the basic blueprint, which for you to define the analysis-ready data, especially define your own product family specification, right? So those are the current definition in the CS ARD. Sorry. For this new OGC ARD working group, of course, is going to make those into a standard description. And for now, I think it's I don't know, it's my understanding. Dr. Lieberman may correct me if I'm wrong. So basically, we are looking to utilize current those ISO standard or OGC standards, specifically for this one might be ISO 19157 data quality for describe those different how we map to describe those at the collection level and also at the per pixel level or granular level, which how we're going to define those things and link those models to describe the different data quality. For the problems, I think we're going to link to the ISO 19115-2, which is the current, used to be that include both data quality and the provenance. Now the data quality part is separate as ISO 19157, and then this provenance is still left in the ISO 19115-2, which is more on the imagery and the graded data. So that I think that's basically we're going to remap those and use link those UML models to describe those data quality. And that's currently the direction of the developer in the analysis-ready data for the data quality part. I think I wanted to bring up another one is the Trinidad markup language for artificial intelligence. This is just I think it's completed the first version of the standards, which also have an emphasis on the data quality part. And with this, they specifically use the ISO 19157-1. Okay, -1 to describe those things. So this basically also have two levels. Of course, basically the collection level, which the whole data set, the whole training data set, right? Also have the different elements, which is depend on the elements, the description. So for the collection level, they have a general description of the accuracy, consistency, and different aspects. And for the element level, of course, is also looking into the logical consistency, temporal consistency, and those basically ISO 19157 aspects or thematic consistency. So also they tested on the different scenario. So those are the three big group of typical scenarios which utilize those training data set. One is the scene classification or scene recognition. And the second one is object, based on object. The third one is based on the pixel level, and they picked the three type. One is land cover, land use change, land use, and also the change detection, also 3D information. And you will see a little bit of slight difference, where those data quality elements will be used in those different scenarios. I think I'll stop it here.
Okay. Now we are into the Q&A and the discussion. So we have a co-chair, Bob and David, to moderate. Yeah, right behind you. Okay.
Yeah, thank you very much, Sean. We have questions online and here. David's going to be handling the online questions. Do we have anybody in the room here with a question now, or should we go online first? The questions? Okay, David.
So I'm going to put a caveat here that I'm actually relying heavily on Rama and Yaxing to help fill in the notes document. I have a Q&A session in the notes. So if you're following along in our notes document through KikoChat, we have a Google Doc here. And if you scroll down to Q&A, you'll be able to see a list here. And I've populated questions also just for myself even, just so I have them pre-documented ahead of time. But the first question we have, and I don't know if Rebecca Ringet is on the line or or in the room, but we have a question from Rebecca, which is how can a discipline-specific metadata model align with NASA's SPD 41A requirement for all data sets to be indexed as part of the NASA catalog of data? Has someone else worked on this? And so we have a preliminary answer from Michael on the call, and maybe Michael, you can just kick us off with your answer, even though you wrote it down, but.
Sure. Yeah, no, I mean, I'm not being facetious here, but I mean, I guess the question I had back to Rebecca was, you know, the NASA metadata model is insufficient for incorporating metadata from other disciplines, right? And I think the question here is like, you know, I think Rebecca is like doing heliophysics and like I'm an atmospheric scientist. So can she populate, like if there's some, you know, effective, you know, I don't know, solar particles on clouds, for example, would that be, if that's an interesting data set, would that be something that we could populate in the NASA side of it? And I guess that's a question back to her. Is there just an insufficiency there, or what's the problem?
So I'm online. Thanks for taking the question. So I'm looking at this problem from kind of an airplane view. My colleagues are the ones that are deeper into this. But the problem that we're looking at is, you know, this SPD 41A requires all the NASA data sets to be in their index. Well, do we do that through our domain-specific metadata model, in this case space, or do we have to make a separate alignment with the catalog of data? Is that separate work? And maybe someone else has done this or figured out a way to automate it somehow. Well, I'm assuming that the data sets exist in our archives, but they're not on the NASA catalog. So I'm assuming that link has to be created somehow. I'm wondering how.
Rebecca, this is Peng. Are you aware of work by the NASA SMD Science Discover Engine?
Yes, surface, only the surface of it.
Okay, I think some of the challenges you are talking about are trying to be addressed there.
Okay.
Do we have any other insights from anyone in the audience here on this question?
So how about the data product development guide? It give you some details about metadata, what you should put in, you know. Yeah, but it would be nice to have a software, you know, is it even better? Yeah.
Surely, yes.
Yeah. Earth science, yeah. Different division, okay, yeah.
All right, so we have another question from Rebecca on the line. This one's directed specifically to Chris Schubert. Are the survey questions available? And so Chris, I know you already answered this, but for the folks that are in the room who haven't seen this yet, maybe you can go ahead and kick us off.
Yeah, I can reply. So it was not or we didn't take the action to publish this. It's public available on our desk and Google Desk or folders here, but we want to have or we want to publish this, yeah, together and as I mentioned also in the chat, together with our consultation and discussion process. So because there's a lot of implicit information and it's nice to share this.
Is there a related question on that? Does somebody have their hand up?
Yeah.
Just on Rebecca's earlier question, the data sets documented in a disciplinary catalog can be cited, so to speak, if we had usage-based discovery capabilities to link data between the two catalogs. The Discovery Cluster has been looking at that problem for a little bit. Don't know if that really answers the previous question, but just a thought.
Well, thanks, Jonathan. Do we have another question here in the room? None?
Okay, so this next question is from Hazem Mahmoud. I hope I'm pronouncing that name correctly. Directed to Jennifer Wei. I don't know if Jennifer is actually on the call, but we might have representatives in the room who might be able to answer it on Jennifer's behalf. The question is the code available online for pyroscope gridding?
I don't know. I think you probably, yeah, I will ask Jennifer, yeah.
Okay. And then we have another question from Rebecca. This one's directed to Benita. The question is, how was the publication library assembled?
So the short answer, come to the poster session tomorrow and see me. The long answer is that we searched for publications from Google Scholar, Web of Science, Scopus, DataCite, and Crossref, and we search all of the sources by use this dataset device. And then we created a workflow where by January, we collected 17,000 publications directly citing these datasets.
Thank you very much, Rita.
So there's some related questions, and I think these might be related to Rebecca's previous question, but also from Rebecca, which is, let me see if I can. Yeah, so it says you mentioned using the problem with using different sets of tools to use the data, but shouldn't this be expected since each problem tends to have custom software?
Yes, that is possible, but from the interdisciplinary researchers' perspective, that's very inconvenient, and I think we need to find some way out to resolve that issue. But again, users, researchers can use either R or Python or whatever the tool they want to use. But I think it's good to have at least the data formats, to have the data sets in the formats that can be accessed by at least a library or two, that we don't have to hunt out for, each data set has a find out library that works with each of the data sets. I think that's very inconvenient for the users.
Thank you very much, Benita. The question.
I was wondering if you could speak a little bit to sort of the skills that interdisciplinary researchers might need in order to most effectively use these data sets, or whether you see skills gaps in specific disciplines that might be needed to be filled in order for these to be most usable, or other types of solutions to kind of the varying types of tools and skills that are across different disciplines for even judging data quality or integrating data in these important ways.
I hope I understood your question, but yeah, from the interdisciplinary researchers' perspective, one thing, one skill really good to have is the Python skills again, right? So, use GitHub, like collaborative resources like GitHub and all that. But also from our perspective as a data center or SDIS, it's good to provide those tools that works with data sets across different data. So and so there are two ways, right? So data set, users are not even within the users, there are different level of expertise. So if we provide such tools, we are addressing the novice users or the new users or the beginners. But if we provide some resources like Jupyter Notebooks, and that uses the tools or the applications or packages, then and that works for data sets across, I think that would be something different. So again, we're talking about users from having with a different level of expertise. I don't know if I answered the question.
Thank you, Alexis and Benita. Any other questions while we're in the room? Okay, back in line.
Yes, we have a question. And by the way, Rebecca, I think that your other questions might be covered in tomorrow's poster session. So we do have other questions, if it's okay, if I can get on with those as well. So the next one is from Ann Vega. So it's not sure who this is directed to, but it says, for those not familiar with NASA, I just Googled NASA's Earth Observing System Data and Information System, EOS-DIS, is designed as a distributed system with major facilities at NASA's Distributed Active Archive Centers, also known as DACs, located throughout the United States. And so it's, I guess, more of a statement, but we have a response from Rebecca to Benita, I guess, relating to this, which is, how do you get users to respond to a complex survey? And that might be another question related to tomorrow's poster session, but I'll.
So if you're talking about the survey that I just mentioned there, I mean, I can share that link as well, but what we are looking at, we are asking users that if they have used any of the data archives user interface or the data source that incorporates all this data archives, and see from their their experience on using that particular site. Do they find how do they rank, identifying the data sets versus narrowing down? So those are the questions that we have, but the survey not necessarily means that the users, interdisciplinary users, must have used one of the NASA DACs, but there are also open-ended questions. If you have any issues, would you like to share? So that kind of questions also we have at the end. But again, Rebecca, if you're interested, then I'm more than happy to share that survey with you as well. Thanks.
Oh, thank you, Benita. Yeah, and to add to that response, in terms of getting users to respond to your surveys, I've conducted a lot of surveys. And I should tell you that it was a lot easier 20 years ago and even longer because the web wasn't saturated with all these surveys that we're getting every day. I'm actually getting multiple surveys every day. But what I find works is if you do have a survey and you're trying to get respondents, you should make sure that your questions are well formed. Because sometimes if people are getting, say, 3 or 4 surveys a day and they say to themselves, I'm only going to respond to one of them, and you go to respond to your survey and you see that the questions are not well formed, what I do is I stop. If the questions contain presumptions that I don't think are valid or aren't really even formed well enough for me to understand what they're asking, I say to myself, well, whatever I respond here is not going to be really valid because I'm not interpreting their question. I don't know what they really meant. And so to me, answering that kind of survey is a waste of time. So I would then answer the next survey that I get that day, if I'm only going to do one a day. But everybody has their own criteria, but I think that if you have better questions, you'll get more responses and probably better responses too. Thanks. Any other questions here online or? Yeah.
I'll just say I have some dialogue that I did with Michael offline, but I did it all in the notes document. So if anybody wants to see that regarding challenges with engaging epidemiologists and remote sensing scientists, you can read that in there. But I think we're out of time. So.
All right. I think that's all we have. Yeah, and we hope to see you at our monthly telecoms and the future ECIP meetings. So to continue our effort at improving information quality. Thank you so much.